That's really quickly. Shh. I was a bit soft here as well, so you can take this. Oh, yes. So I was a bit soft in this section here. You got to read. Shh. Find the lengths of the horizontal lines and the offsets, taking each grid unit as 5 millimeters. Record the lengths in the diagram. Now, I'd be a bit more thorough. Slightly more thorough. Most of you did a pretty good job. So I'd say 1.5, 1.5. I'd end up doing them all just because it's thorough to do most of them. Now, we do above and below. So that is 4 blocks, which is what? 2. That's 2 up here. Now, I suppose you probably should write in centimeters, or you can just write a little note, everything is in. You must write a little note just to explain to the examiner what you did. Okay, so you can do the millimeters if you want, but there's really no need. Okay, next one is what, guys? What's that? 3 on top, 3 on the bottom? 3, 3 after that. 4, 2 after that. 5, 3 after that. 4, 2 and after that. 4.5 and 2.5. Some of you had 7.5 written there, which is an issue. Now, the last one, does it go straight up? Doesn't go straight up, does it? What does that mean about that height? Now, that's where a lot of you threw away your first. So the grading system for this question would be 0, 3, 7, 10 within reason. That's what I gave for it. I didn't punish for the 0, but just for future reference, putting the 0 just in case, okay? Now, I think that's pretty thorough, okay? It does say something about the length of the horizontal line. So to me, I haven't quite answered that. So I'll just put a little thing here. Yeah, all that's 9, no bother. Just in case, right? Better to overcook it than undercook it, if you get what I'm saying. Okay, next thing. Use the trapezoidal rule to estimate the area of the scale drawn. We do h over 2, first plus last, 2 times remainder, okay? Now, what we're going to do here is 1.5 divided by 2. Your first is 4, but your last is 0, not 7.5 or 7. So that's where a few of you would have turfed away some of your marks there. 2 times remaining, which is 6 plus 6 plus 8 plus 6 plus 7. Close it down and you're done. 52.5 centimeters squared. Now, I'd like you guys, I scribbled out part C, but I'd like to do part C with you now just for future practice, okay? So, essentially what this thing looks like, it's essentially a lake, isn't it? Or does it say it's a lake? A pond, okay? Now, the assumption is that the pond here, so this is my attempt at what the trapezoidal rule looked like a second ago. Is that all right? It's pretty crap, but you get the gist, don't you? Now, what I'm going to do here is going to clone this, and what I'm going to do is going to put one above the other. And what I'm trying to get at is I'm trying to do like a depth thing. So you imagine that, you're imagining that like an empty swimming pool, that the base of the swimming pool is the same as the top. So what we're assuming is the bottom of the pond is the same as the top. A bit like a loaf of bread. If you slice through it, the shape of the slice will be the same no matter where you slice it. Does that make sense? All right. So the first thing we know is that what do we know about our area of the face? What did we say? We got 52.5 what? Centimeters squared. Now here's what we have to do. How do you convert centimeters into meters, okay? So, if 1 centimeter is 100 meters, what's 1 centimeter squared going to be? Only for this drawn, for nothing else, only for this drawn. 10 multiplied by 10, which is 100 meters squared. Is that okay with you guys? Now, multiply 52.5 by 100, and what do we get? 5,250 meters squared. That's how much, that's the area of the water. Now, how deep is the water? So what's the volume of water in that pond then? It's the area of the face multiplied by the depth. So I know you guys didn't have this question, but it's worth just doing it now anyway. Yeah, you kind of did. 3,937.5 meters cubed this time because it's volume. Huh? From the last answer. Here. And then I converted it to meters squared because it says that 1 centimeter is 10 meters. Implies that 1 centimeter squared is 100 meters squared. Only for this drawn, okay? Okay, let's do this. Now, for all intents and purposes in the future, do you know the things you fan yourself off with in our country? It's always that one for a cone. You got it? And for the next thing I'm going to say is, if this is the red, if this is the circumference of the red circle, what's that the same as? It's the same as that part there. So if I draw around, the red circle is the same length as the green line. It has to be to join up and make a sphere. Now, anytime you guys have ever eaten a cornetto in your life, there's usually a cardboard piece at the top that says cornetto on it. And you take it off. Otherwise, your ice cream, the top of your ice cream will be exposed. Okay? So there's the curved surface area, which is the red area. Oh, sorry, we'll call it green because it's just after making it. So that's the cone has a green wrapper. That would be your green wrapper. And then your blue top would be that part there. Okay? Just for future purposes, okay? Now, there we go. Okay, now let's move on. The answer is B. Assume there's no overlapping wrapper, calculate the area of the paper required. Now, what does it say about the slant length? Slant length is 16. Okay, radius is 3. There you go. So now you have pi r L will get you the curved surface area part, and pi r squared will get you the circle on top. So it's pi r L plus pi r squared, pi times 3 times 16 plus pi times 3 squared. You end up getting 57 pi, which will convert into 179 centimeters squared. Who got that? I know, yeah. You do pi times 3 times 16 plus pi times 3 squared to get 57 pi, and that in turn is 179 centimeters. Well, good. Alrighty. Now, next thing. Do we have any questions after that? Oh, calculate pi. Now, I'm going to go back to the diagram to help me with this, okay? And actually, what I'll do is this. I'm just going to grab this diagram here, and I'm going to use this diagram to help me answer the question. New page. Okay. So, calculate pi is the question, isn't it? So, what have we learned earlier? We have learned that we know that the red length here is the same as the green length here. Everybody cool with that? And we know that the length of the green part is, length of green part equals length of red part. What's the diameter of the radius of the red part? 3. Therefore, the length of the red part is 2 pi r, which is 2 pi times 3, which is, everybody, 6 pi. So the length of the green part is also 6 pi. What's the slant edge? 16, no bother. If this was a bigger circle, what would the so this is the green part. The green part is a lot smaller than the full circle. Would you agree with that? What would the size of the full circle be? 2 pi times 16. If you were to run a lap of the big circle, what distance would you cover? 2 pi times, which is how much? 32 pi. What fraction of the circle do you actually have? You have 6 pi divided by 32 pi. So what fraction is it? Just put it into the calculator. What's 6 over 32? 3 over 16. If you have the full circle, how much angle do you have? Okay. And then what can I multiply this by? 3/16 of 360, and that'll get you 67.5 degrees. Right, that's one way to do it. Yeah, please, yeah. I think that's a nice way. All right, let's look at this one. Now this one's radius is half the diameter, radius is 3. Somebody knew the radius was 3, wrote nothing to do with the radius being equal to 3, and then on the next part had it as 3. He knows it's 3. He uses the next formula as 3, but he never wrote down in question 1 that the radius was 3. I have no idea. Oh, I don't think I get anything. Now, how do I get 113.1 centimeters cubed for that? Okay. Now, here's the part where you guys just went slightly awry with this, okay? Now, what I want you to do is you visualize 2 boxes, okay? Once again, I tend to draw diagrams more than you guys would. So, I just draw a rough diagram in my head here, so I'll just change the shape a bit. It's a bit closer, isn't it? So what's a 6 by 8, isn't it? Now, okay, so that's 6 by 8. Now, most of you figured out that it's 5 on the other side, right? That wasn't too bad. But what you failed to realize is that you're meant to be figuring out the size of the object, not how many you can stack in. So you draw your box like this, no bother. Okay. Now, what I'm trying to get you guys to visualize is this: that if you have 6 circles on the bottom, so see that you have a couple of circles down here like that, yeah. Now you have 6 of them in a row on the bottom, okay, and then you have 8 of them going in this direction here. Do you see that? All right, that's 6 times 8, which means each section will have 48. There'll be 48 balls stacked all on the bottom layer, 1 ball in height. Do you get what I'm saying? A bit like a snooker ball rack. That's 1 ball in height, isn't it? All right. Now, you need 240 balls. So you do 240 divided by 48. And most of you knew that that means it's 5 balls high. 1, 2, 3, 4, 5. Is that okay? Now, what you failed to do, however, was get the sizes. What is the width of 6 balls? It is. What is the diameter? What's the diameter of the ball? 6 centimeters. Is that right? So what's 6 times 6? 6 times 6. 6 balls by 6 centimeters is 36 centimeters. Okay. The next one. 8 balls by 6 centimeters wide is 48 centimeters. And finally, 5 balls by 6 centimeters in height is going to get you 30. You are doing 30 by 36 by 48. So 30 multiplied by 36 multiplied by 48. You should get 51,848 centimeters cubed. All right, who got that one? All right. Now, next part, guys, is when you fill an object with all these balls, well, basically, lads, there's going to be a lot of empty space, isn't there? Okay. So guys, there's sometimes a lot of empty space in containers. So when you put three tennis balls into a container, there's often empty space, okay? So what you guys are going to do now is, it says, is not taken up. So you fit 240 of them, and each of the 240 of them is 113.1 centimeters cubed in volume. This makes 27,144 centimeters cubed. You want the volume that is not taken up. So we take that away from 51,840 minus your 27,144. You then get 24,696 centimeters square cubed of free space. This is space that's not taken up by the balls in the box. All right. Next thing is you divide that by 51,840. Everybody cool with that? And you multiply that by 100 to find out what percentage of it is, and it's 47.64%. That's similar to the question we just did. What you guys are assuming, some of you assumed that you did volume of box divided by volume of can. Gives you the number of cans. But why is that not correct? Because the cans cannot take up every bit of space in the box. See the gaps in the middle? See this gaps? This is wasted volume. So you can't do it that way. Okay, you have to do it a different way. Now here's the different way I propose you do it. Okay? Now, it says 30 centimeters. If it's 10 centimeters, if it's 10 centimeters in height, let's assume 30 centimeters is the height of the box. Not doing the fancy ones anymore. Right, if 30 centimeters is the height, how many cans can you stack end on end? 3. That's 3 cans in heights. If you have 40 centimeters wide, how many 10s can you fit into 40? 4. 3 multiplied by 4. And finally, if you're 60 centimeters in that direction, you're 60 centimeters long, okay, basically, how many cylinders can you fit in there? 6. 3 by 4 by 6 gets you 72 cans, or my standard Saturday night. Now, okay, next one. In response to demand, Scully Soups wants to produce a larger family-sized can of soup. It has been suggested they double the radius. Now, guys, what happened there is when you double the radius, it's going to be 20. So you do pi r squared h. The original can was pi times 10 squared times 10, which gets you, oh, sorry, I'm wrong. The diameter was 10, which means the radius is 5. That'll be 250 pi. However, if we double the radius or double the diameter, we'll end up with 10. And then when we put that into the calculator, we get 1,000 pi. Now, when it's 4 times bigger, the word is quadruple, not triple. No, not true. 4 times bigger. Maybe Jarvis needs to tell you the answer to that next time. Scully Soups decides to produce a family-sized can which is 242% larger than the standard one. This means you multiply your original volume. Do we have an original volume? Do we have original volume? We have to get this volume here, and then we multiply it by 2.42. Lads, quiet please. Lads, we have it there. It was 250 pi. You then multiply that by 2.42. to make it a new size of 605 pi. It's still a cylinder, which means it obeys pi r squared h. The h value is now 14, it says it in the question, but we don't know what the r squared value is. 1 sec, lads, just give me the end here. We cross off the pi's, you divide by 14, 605 divided by 14, you square root the answer, and long and behold, you get a radius of 6.6 centimeters. Way!